Are you able to see the screen?
Yes, sir.
Okay, so this chapter electrochemistry, we are going to deal with the last topic of this chapter, that is your corrosion. As I told you to study about this corrosion. So we are going to complete this chapter in half an hour. Then we'll do some questions based from this chapter, and then from the next class, we are going to start chemical kinetics. So see, what is corrosion? Basically, this corrosion arises due to rusting or due to rust. What is this rust? So basically, when iron, not iron, basically ferric oxide, Fe2O3, react with some molecules of water. That means let's take XH2O. This is your rusting. This is your formula for rusting. Are you getting my point?
Yes, sir.
So this is your rust. Let's take an example. If you have a block of iron, let's say this is your iron. So what happens on the surface of the iron? This block of the iron is directly in contact with H2O. Let's take this H2O from moisture from its surrounding. It is in direct contact with O2 from the surrounding. It is also in direct contact with CO2 from surrounding. So I'm going to just explain this from very basic. This H2O, that is moisture from the surrounding, O2 from the surrounding, and CO2 from the surrounding as well. Now see how corrosion takes place, or how the formation of this Fe2O3 takes place. I'm going to explain this. Now see what happens. In the first step, this hydrogen, basically this water, or this water from the surrounding, react with carbon dioxide. And carbon dioxide in nature, it is acidic, so it will form carbonic acid, H2CO3. This is what form. This is your carbonic acid. Austin, are you there? You were absent in the last class, not on Tuesday, in the previous week. Why? No, you are not audible. You are not connected. Okay, I'll talk to you later first. So we are studying corrosion, the last topic of this chapter. And here in corrosion, rusting takes place. And for rust, this is the formula Fe2O3 dot XH2O. Now, how this formation on the iron block takes place. So I just took an example of this is your iron block, which is directly in contact with H2O, O2, CO2 from the surrounding. In the first step, H2O will react with CO2 to form H2CO3, which is an acid known as carbonic acid. Now, this carbonic acid, basically, this is your electrolyte. So basically, this will be existing as 2H plus CO3 minus. So in the first step, this will take place. Now, in the second step, what will happen? I'm going to show you. In the second step, what? This iron will be oxidized into Fe plus 2. This iron will be oxidized into Fe plus 2. So basically here, iron will be oxidized into Fe plus 2. That means it lost 2 electrons. And you know what? Wherever in the iron block, this will take place, that is known as anode, because you have studied this in electrolysis or electrolytic cell, that at anode oxidation takes place, and you can see here oxidation is taking place. Are you getting my point, both of you?
Yes, sir.
Yes, sir.
Now, do you know, practically it has been found that this has inert oxidation or reduction, you can take inert oxidation. That means oxidation potential that is equal to your plus 0.44 volt. So can you tell me what will be the value of inert reduction for this? What will be the value? It will be minus 0.44 volt, because I told you only the sign changes. they are numerically equal, oxidation potential and reduction potential for a particular metal, it's same, only the sign changes. So as you can say, if I have written here E naught oxidation is plus 0.44 volt, that means E naught reduction will be minus 0.44 volt. Is that clear?
Yes, sir.
Yes, sir.
Now, in the third step, what will happen? Since here you can see the oxidation takes place, that means it is at anode, and in the third step I'm going to show you the reduction, and the reduction takes place where? At cathode. So how the reduction will take place? Now you can see this is your H plus, this is your H plus. So this H plus will do what? It will gain 2 electron. Basically we need to balance it, don't write it now, or you can write it and again you have to write it. Is my video lagging?
No,
No,
sir.
sir.
Okay. Now see, this 2H plus will gain 2 electron and it will convert into 2 hydrogen atom, into 2 hydrogen atom. Now see what will happen. I'm gonna show you this 2 hydrogen, will combine with O2 oxygen gas. This 2 hydrogen will combine with O2 oxygen gas to form H2O, Now, in order to balance it, I'm gonna show you. In order to balance it, let's say oxygen on the left hand side is 2. Oxygen on the left hand side is 2. So I'm gonna multiply it here so that oxygen will be balanced. But now hydrogen is 4. So what we need to do? I'm going to make this 2 hydrogen as 4. Now, how does this hydrogen will come? So you need to multiply this equation by 2. You need to multiply this equation by 2 to make it 4 hydrogen. So what will happen here? I'm gonna show you this. If there are 4 hydrogen, then we need 4 electron as well. And it will give you 4 hydrogen. Now you have only 2 electron that lost to be gained. So this will also be multiplied by 2. So if you are going to multiply it by 2, so what will happen here? So basically it is just balancing. If you are going to multiply it by 2, so what it will be? It will be now 4. Are you getting my point? Yes or no?
Yes, sir.
Yes, sir.
Now you can see that this 4 hydrogen O2 give you H2O. Basically it gained 4 electron, then it becomes this. So this process is at cathode, where it is at cathode, because reduction is taking place, Now you can see overall reaction, what we do at overall reaction. Oxidation half reaction you are going to add, and reduction half reaction you are going to add, and you will get the whole reaction. So you can see on the left hand side you are going to add this. So you can see on the left hand side it is 2Fe. So I'm gonna add 2Fe. What is it? What it is? You can see this 4H plus. Just wait a minute. This is not the reaction. We need to add this and this final reaction. So you can see that 2Fe plus what it is? 4H plus O2. Just wait a minute. Let me finalize this. 4H. On the right hand side, you can see 2Fe plus 2, and then 2H2, and then 2H2O, 2H2. Are you getting my point, both of you? Let me show you. This 4H is wrong. Why it is? You can see. Let me show you. This 4H. It's not right. This 4H and this 4H will be cancelled. Yes or no? Tell me. Mahmoudin and Austin.
Yes,
This
sir.
4 electron and 4 electron will also be cancelled, because on the opposite side. So there will be 4H plus here that I left. So this is your cell reaction or overall reaction, you can say. So basically in the same way, like electrolytic cell, there is a reaction taking place. And in this way, Fe2O3 will form. I will show you again. So please do write it first. Then I will explain again. Let me know when to slide up, slide down. Austin, why were you absent in the last class?
When was the last class?
Like previous week on Thursday.
Oh, yes, sir. I had a test the next day, periodic test.
We'll try to balance all these things.
Yes, sir.
So, mom, are you done with this?
Yes, sir. Pretty sure.
Yeah, Austin.
Yes, sir.
Okay, I always forgot to write the E naught for this this reduction. So E naught reduction here has a value 1.23 volt. So since E naught cathode and E naught anode is given, you are going to calculate E naught cell for me. You know the formula of E naught cell, right? Which is E naught cathode minus E naught anode. Today I'm going to give you questions from NCRT and let's see how much you can solve. I think you were practicing NCRT, right? So could you explain the third step again? Yeah. So see, as you know that in if someone has lost electron, then someone will gain that electron, yes or no, Austin?
Yes, sir.
So basically, before that, when I didn't balance it, Fe lost goes in Fe plus 2. So if it goes in plus 2, so it will lose 2 electron. But in the last step, we saw that we must have 4 hydrogen, and that's why we need 4 electron. So basically, here 2 Fe will come together to give you 4 electron. So this is at anode. Now 4H plus comes from where? Carbonic acid. From here, you need to do balancing as well here. Are you getting my point?
Yes, sir.
So if you are going to multiply it by 2, this will be 4 and this will be 2CO3. So 4H plus will come and gain this 4 electron and becomes 4 hydrogen atom, not molecule. And this 4 hydrogen atom will come in contact with O2 that is present on the block from the surrounding. Are you getting my point? And becomes
Yes, sir.
H2O. And now you are going to add this anode and this cathode reaction. So if you are going to add this, you can see 2Fe and this 4H plus here, and you can see this 4 electron and 4 electron will be cancelled, and this 4H and 4H will also be cancelled, and then comes O2 and then give you 2H2O. Then you can see 2H2O on the right hand side and Fe plus 2 also on the right hand side. So overall reaction, basically this is the overall reaction. And if you are going to calculate inert cell, then what will happen? Inert cathode, you can see at cathode, what is the value of the reduction potential? 1.23 minus. At anode, what is the value of reduction potential? We take a reduction potential value, not the oxidation potential value. So it will be minus 0.44. And accordingly, you can add this. And what will be the value? Let me know. Very good. Humam, have you got the answer? What will be the answer? Both of you done with this?
Yes, sir.
Yes, sir.
Now, as you know that I had written the formula of rust as Fe2O3 dot XH2. So you can see what will be the oxidation state of this Fe2? That will be plus 3. But what we have got? We have got Fe plus 2. Yes or no? In Fe2O3, what is the oxidation state? It will be the plus 3 for iron. Are you getting my point? Yes or no?
Yes.
If you don't understand, just let me know. I will again explain it. You can see Fe2O3. If you want to calculate the oxidation state of iron, let's take X. There is 2 iron, so 2X plus how many oxygen? 3 oxygen. For oxygen, what is the oxidation state? Minus 2. Overall charge is 0. So if you are going to calculate it, 2x minus 6 is equal to 0. And here 2x will be 6 and x will be equal to plus 3. But when we had the reaction, overall reaction, what is the oxidation state of iron? Plus 2. So how does this formation take place? So the in final step, what happens? This 2Fe plus 2 will come in again contact with moisture from the surrounding H2O and O2, and it converts itself into Fe2O3 in Fe2O3, and you can see it will be converted into Fe2O3 plus 4H plus. To balance it, you can multiply it by 2 and you can multiply it by half. Now here this Fe2O3 formation took place, and this Fe2O3 will come again in contact with, why it's not working. This Fe2O3 again will come in contact with X molecules of water and then rust took place. Fe2O3 dot X H2. Got it, both of you?
Yes, sir.
Yes, sir.
Please do write it. So today we are going to practice from NCERT. Let me know when you are done with this. Very good, Ajay. Mom, are you done with this?
Yes, sir.
So I'm starting this question from NCERT. I will give you the question which is important, and I would suggest both of you to please complete this NCERT question, exemplar, assignment, and diagnostic test, each and every question. Here are chapters completed. If you have any doubt from the previous topics of this chapter or anything, just ask me. Arrange the following metals in order in which they displace each other from the solution of their salt. As I told you in the ECS, electrochemical series, what happens here? You know that more reactive element, the element which lie above in electrochemical series that I gave you, will displace the one which lie below. So what do you think out of this five, which is above in the periodic table, ECS? I think magnesium. Yes or no?
Yes,
Then
sir.
comes your aluminum. Magnesium can replace all this. Then comes your aluminum. After that comes your zinc. After that Fe, and copper has positive. It will be the lowest one. It cannot replace all of these four, but magnesium can replace all the other four. Aluminum cannot replace magnesium, but can replace zinc, iron, copper. Zinc cannot replace magnesium and aluminum. Basically, this will be like this: magnesium, aluminum, zinc, iron, copper. Got it? Mom.
Yes, sir. Got it.
Okay. And Austin, are you getting these points? These are very
yes, sir.
easy, and you know these questions. To solve these questions, you have to remember, or at least there should be some trick to to memorize this. This is very important. Not all you need to remember, but some of them you need to keep it in mind. Please do this. Are you done with this?
Yes, sir.
Which one will be the most reducing? What do you think?
K, potassium.
Uh, Humam, did you say this?
Yeah, okay.
Okay. Very good. As I told you, E naught R directly proportional to reducing power, right? No. Just wait a minute. It's time. E naught are directly proportional to oxidizing power and inversely proportional to the reducing power. So the one which has the lowest value of E naught R will be the highest reducing agent. So the answer will be potassium is the maximum, then comes your magnesium, and then comes your chromium, and then comes your Ag, right? Ag will be the least reducing agent. Right, both of you?
Yes, sir.
These questions are very basic. Basically, it will cover your basic concept. Have you solved any questions of NCRT? Honestly, please do let me know. Austin,
This chapter, no, sir.
you haven't solved a single question from NCRT,
Not for this chapter, sir.
not from electrostatic. So it's not good. You should have solved it. You are both of you. Please do this. depict the galvanic cell. So you are going to write the representation for this reaction. Then which of the electrode is negatively charged? I think you can do this. And the carriers of the current in the cell. A reaction taking place at each electrode. Very easy. I think you can do this. Let me know if you are facing any kind of problem. Done, so very good. Uh, Second question, sir, what does second question mean? Second question, like, yeah, the carriers of the current flows due to electron or due to ions. So in this, current flows with the help of ions, right? Basically, ions are the carrier of current. Ions, this is the answer for the second question. Ions are carriers of current. Are you getting my point?
Yes, sir.
So free electron are there due to which conduction of electric current takes place. But here ions are carrier of electric current. Okay. And you know how did you represent it? I'm gonna show you. This is oxidation takes place Zn to Zn plus 2. So oxidation zinc, that means at anode we show anode first, then double slash, then Ag plus come into play, and then Ag plus slash Ag. This is the answer for the depict the galvanic cell in which in the cell in which the reaction is. Are you getting my point? This is the answer. And you can see which electrode is negatively charged. So the first answer, anode is negatively charged. So we can write zinc electrode, which is anode, is negatively charged. Got it? Now the last reaction, individual reaction at each electrode. You know, at anode, oxidation takes place. So this is Zn converting itself into Zn plus 2. But in exams, you are going to take care of this. You are going to write the physical state as well. That will be more beneficial. So this is your at anode. And at cathode, you know that if it lost 2 electron, just wait a minute. We need to write as well this 2 electron, 2 electron. Now, what will happen? Ag plus come into play, and since it lost 2 electron, it will gain 2 electron. And to gain 2 electron, you should have 2Ag plus and convert into 2Ag, and this is your at anode, and this is your at cathode. I think it's both is clear to both of you, right?
Yes.
Okay, I'm gonna give you a very easy question. I think you can do this. Then we'll move to the important topics. If you really want to improve your marks or the concept, you should go through NCERT 100% if you get enough time. Please do this fourth question. Calculate the standard cell potentials of galvanic cell in which of the following reaction takes place. E naught cell you need to calculate, and delta RG naught, that means delta G naught. I had given you the formula. Please do it. Any answer? First, calculate the value of E naught. Oh, wait a minute. I need to give you the value. Just wait a minute. Oh. Value is not given, right? Okay, I'm gonna give you value for this reaction. First reaction, E naught, Cr plus 3 slash Cr is 0.74 volt. And E naught, Cd plus 2 slash Cd is given as minus 0.40 volt. And for this, E naught just wait a minute. E naught Fe plus 3 slash Fe plus 2 is given as 0.77 volt, and E naught Ag plus slash Ag is given as 0.80 volt. So basically the value was not given in NCERT, so I forgot to write it. So please do it. Now you can do the answer. You know that E naught cell, if you are going to calculate what will be the value E naught right minus E naught left, or E naught cathode minus E naught anode. And I think you know what happens at cathode and what happens at anode, right?
Yes, sir.
Okay, please do it. Any answer? Any answer? No answer.
E dot cell I found out, but delta RG I could.
Okay, E naught cell for what? The first reaction. What is the value of E naught cell for the first reaction?
Plus 0.34.
Plus 0.3 volt. Very good. You know what? Delta G naught or delta RG naught is equal to what? Minus NF E naught cell. Yes or no?
Yes, yes,
Austin, have you got the value of E naught cell for this reaction?
Yes, sir.
So n number of electron, you can see chromium 1 is going from 0 to plus 3, and there is 2 chromium, so the value of n will be 6. F, you know the value 96,500 coulomb, and E naught cell you just calculated what it is. You just told me plus 0.3 volt. Please do apply it
okay.
and calculate. So you can see it's quite easy, right? Number of electron is 6, nets 96,500 coulomb, and E naught cell you just calculated plus 0.34, and you just need to multiply it and you will get your answer. Isn't it easy? You have taken too much time for this little question. Mom, any answer for the second one? Or you are simplifying this, calculating this?
Second one I got plus 0.03.
Plus 0.03. That's good. E naught cell. And please do calculate the value of delta G naught. Austin, what about you? Is there any problem in this type of question?
No, sir.
Okay, that's good. Let me know if you have got the answer of the previous question so that we will move to the next question. I need to show this question. This is a very important question. No, no. Is this the second question? The second part, answer of the second part.
Yes, sir.
2850 joule per mole. That's good. Good. Almost there is minor differences, but it's good. Okay, there is another question in this, I think. And that is your equilibrium constant. If you remember how to calculate equilibrium constant, you just calculated E naught cell, delta G naught, and uh, this equilibrium formula you can see from class 11th. These formulas are very important. I'm gonna write again. Forget about this 3.5 question. Concentrate on the screen, which I'm going to tell you. The first one is, if you want to calculate E naught cell, you should know it is E naught cathode minus E naught anode, not anode. The second is your delta G naught, delta R G naught. It was like this, and minus NF E naught cell, minus NF E naught cell. The another question, the another reaction that comes from class 11, that is your delta RG naught is equal to minus 2.303 RT ln K. RT ln K. So if you want to calculate log K will be equal to minus delta RG naught divided by 2.303 RT. So please be careful. These formulas are very important. The answer of this question will be directly solved with the help of these formulas. Okay. Please do write it. Wait a minute. Let me remove, since it is in ln K. So it will be minus RT ln K, minus RT ln K. If you are going to convert this into log, like delta R G naught or delta G naught is equal to minus 2.303. If you are going to use this will be RT log K. Got it? And accordingly, you can calculate the value of log K. Please do let me know when you are done with this. Let me know when you are done with this, Mahmudin and Austin.
Done, sir.
Very good, both of you. Now you are going this question that I'm going to show you. This is a very important question. Please go through only, you are going to solve only one part of the question. This. And the rest you are going to solve it at home. Very easy question. You need to write the Nernst equation and EMF of the cell, that means cell you are going to write. I'm going to give you the E naught for magnesium, Mg plus 2 slash Mg, that is equal to minus 2.36, and also Cu plus 2 slash Cu, that is given as 0.34 volt. The rest is given already in the question. You can calculate the E cell. First write the Nernst equation. So will they give the, yeah, they will definitely give the E naught value. Since this question comes from NCERT, the value is already given, that is understood. That you need to see the value from the table of the NCERT. Any answer? Let me know if you are done with this. Very good, Austin. Mom, any answer? Or
1 minute, sir. I got it.
okay, okay. Take your time. Very good. Now go for this question. Very good. And the rest three, I'm leaving it on you. Please do solve this. Let me know when you have got. The answer. Sorry, I just got disconnected. Are you able to see the screen?
Yes, sir.
Okay. Both of you are correct for 3.8. Please go for question number next. Any answer for 3.9? Three point nine, which formula would I have to use? I didn't understand the question. Is it for 3.9, Humam?
Yes, sir.
Okay, any answer from you, Austin, for 3.9?
No, sir.
Okay, so it's all formula based basically. Let me explain this. Okay, see, in 3.9, whatever is given, you are going to write it first. You can see conductivity, and here it is given that molarity is given. Molarity is 0.01. Okay, 0.01 m. At 298 Kelvin, resistance is given as 1500 ohm. Just wait a minute, please. जी सर जी
Sir, you are mute.
yes, yes, I was mute, sorry. So molarity is given, you can see. Resistance is given as well. Conductivity is given, and we need to calculate cell constant, which is very easy to calculate. You know what you need to do? It's very simple. If you remember the formula of cell constant, it is mm, we can write cell constant is equal to kappa into resistance. So simple it is. Kappa into resistance. Basically, this is the modified form of this formula of cell constant. Basically, cell constant, when I had taught you, G star is equal to length of the conductor upon area of the cross section. Area of the cross section. And I also told you that this kappa is equal to cell constant upon resistance. Cell constant upon resistance, G star upon resistance. So this you need to keep it in mind. Very easy questions based upon directly formulas. Is that clear, Humam, Austin?
Yes.
Yes.
Okay, can we move to the next part? How much charge is required for the following reduction? I already explained this in class. Let's see. We'll do it first. Let me know. It's too much. 20. Wait a minute. Let me see it. I'm going to explain the first one. 1 mole Al plus 3. If you want to deposit 1 mole of Al plus 3 to 1 mole of aluminum, 1 Al. So how many electron is there to gain? 3 electron. That means 3 mole electron. 3 mole electron charge. That means 3 Faraday. That means 3 Faraday. And 3 Faraday, that means 96,500, right? So if you are going to multiply it this much coulomb, you are going to get it. And that's correct answer. Mom,
Yes, sir.
got this?
Got it.
Very good. Austin,
Yes, sir.
got this? You have got the right answer. Very good. Go for the next question. Let me know the next answer. And the next answer will be 2 into 96,300, 96,500. And after that, the answer will be 5 into 96,500. 4,82,500. Very good. Very good, Humam. So both of you are done with all these questions. Just wait a minute, please. Are you able to see this question, or should I zoom it?
Yes, sir, we can see.
Okay, only the first part you are going to solve. Very good, Humam. Twenty gram of calcium from molten CaCl2. This question has been asked in NEET. It is from NCRT.
Sir,
Yes.
I found out that in 1 mole of electricity, it requires 2F for CaCl2, but how should I find out like 20 grams of Ca? How
See,
much?
see, whenever CaCl2 is given, you are going to omit the, basically you are going to dissociate it. You will get Ca plus 2 plus 2Cl minus, right? Now
Yeah,
think
yes, sir.
only about this, Ca plus 2. Now it will gain 2 electron to give you Ca, right?
Yes,
Yes or no? Now you can
yes,
see
yes,
2 mole electron, that means 2 Faraday will deposit 1 mole calcium. Yes or no?
yes, sir.
Now in 1 mole, it is equal to its atomic weight or molar mass. So 40 gram calcium. Can I write from 2 Faraday? Yes or no?
Yes, sir, got it.
Now you just need to do this 40 gram of calcium. To deposit 40 gram of calcium, you need 2 Faraday charge. You need 2 Faraday charge. So for 1 gram calcium, you will be in need of 2 Faraday divided by 40. So for 20 gram calcium deposition, you need 2 Faraday by 40 into 20. So you can see this will be cancelled by 2 times, this will be cancelled by 1 times, and 1 Faraday is answered. That means charge required is 96,300, 500 coulomb. Got it?
Yes, I got it.
Okay, if you have got it, Austin, please
Yes,
do
sir.
this as well. The next question. How power cut off? Please do the next question as well.